Hey guys, it's Tiny Tom Logan back with another video for you, and today we're finally going to be taking a look at the Asus Poseidon or Poseidon, however you would like to pronounce it anyway, because I always get corrected on that type of thing. But the essential thing is it's a new Republic of Gamers card, and it's Asus's hybrid cooled graphics card. And by hybrid, what I mean is it's an air-cooled card. It will perform just like an air-cooled card, but it's also got the ability to water cool it as well. So very similar sort of idea to their Maximus 6 formula type MOSFET heatsink array that they've got there. So you can either just use them as air, or you can pump water through them for better cooling, and that's pretty much exactly what the Poseidon is as well. Now that's obviously quite a new thing, that a card can do both. I mean, Asus has tried more kind of unique cooling options before. With the Mars 2, there was the AIO water block system that they had in that, so it pretty much had its own hose and radiator and everything built in. Now that's great if you've got one of those cards, but if you've got two of those cards, then obviously things get very difficult, because you have to start finding places to have all the hose and stuff. But this, if you want to go water cooling, you can obviously add it into your existing loop, or start building a new loop around it, whatever. But anyway, what we're going to do is we're going to bring you in, because I've done all of the testing already. Because obviously I've had to do some air-cooled testing and some water-cooled testing. So we've got this at the end of all of the testing. So the rig is built at the moment with the water block in, which is, or with the water loop in, which is what I thought you would prefer to have looked at anyway. So we'll take a good look at the rig. We'll then move on to talk about some performance and the overclocking, and look at some benchmarks, and I've got some graphs for you as well. If you want to look down, click in the bottom left hand corner of the screen, or wherever it is, because I never remember, I'm sure it's this side. But anyway, click on the review link, you can go and have a look at all the graphs. So one thing I will say that we have kind of incorporated now is I've changed our graph program. So now they're not Flash, they're JPEG. So that it'll work on all your mobile devices now, whereas before it wouldn't, because we were still using Flash stuff, and obviously mobiles are a bit gay with Flash. But also we've put the graphs in order as well, and you wouldn't believe the graph program that we use, really it doesn't like it, so we're having to port things in and out of spreadsheets. Anyway, it takes so much longer, but we hope that you prefer them that way. For the video, I have highlighted where where this card is, just so that you can see it, but you'll see those in a bit anyway. So I'm going to shush my mouth. We'll move on to have a good up close look at the rig. So yeah, need to grab my remote. Okay then peeps, so we've already got the card installed, because I did forget to video it for this section beforehand. But if you have a look on the main review, on the very first page there is the first look video that we did on the Rush Kit channel. We get a good up close look around the card, talk about all the specifications and all that kind of stuff. So if you're interested in that and you want a better look at it without it being in the rig, please go and check out that section of the video. Like I said, you can find it on the website, or you can just go to the Rush Kit channel. Anyway, as we've got things here, I'm going to move us up for a sec. There we go. Now, I know my camera does obliterate red, but this is actually quite a deep red. You're used to the red that you're used to seeing on the Corsair SP120s there at the top, so you're going to get a good idea. This section of the card does light up red as well, and it throbs. It's quite annoying. I've said before and I'll say it again, I wish there was a way that we could either turn that off or just set it to just stay on rather than throbbing all the time. It's also quite a pain in the ass to take pictures of. But we've got it all plumbed in. You can see that we've got a 90-degree fitting coming out the side here. You do need to make sure that you're going to need a good amount of room inside of your case. What I would say is you need to kind of make sure that from your motherboard area you're going to need about 165 millimeters of room to go from your motherboard area to the outside of the barb. So you need that kind of amount of room. Now one thing I will say, if you've got a 120mm fan in the back, you're going to be fine. This is a 140mm fan, and you can see that we've got a fair bit of clearance there, and we're probably looking that we've got probably about 40mm between the outside of these fittings to the outside of the case. So if you've got a 120 or a 140 in the back, as a rule of thumb, I would say you're probably going to be alright, but I just wanted to kind of stress that, so you can just give it a little bit of thought before you start chucking stuff in there and then blaming me that it doesn't fit. So what we've got water cooling wise is actually in the front we have a XSPC bay reservoir with a D5 pump. Now with the D5 pumps they've got a variable pump setting and they go from 1 to 5. I actually run this on 2 just to kind of show you that you don't need your pump, at least with these kind of pumps anyway, you don't need it screaming away, and it does make it very quiet. We've then got 3 SP120 Quiet Edition fans, although they will run at 12 volts. We've got 2 AF140s in the front blowing in. We've got an AF140 in the back also blowing in. So we've got 3 140s coming in, 3 120s blowing straight out the roof. The one thing with the Poseidon, and a lot of people have said, Tom, your cable tidying's not as good as it used to be. But the problem is the clips, normally with a graphics card, that little clip that's there sits on this side, so the cables around like that and they look tidier. But on the Poseidon the clips are actually up on the PCB side, so you can see them from the top, and it just means that you have to twist all the cables and everything round. I probably could have found an easier way to try and make them look a bit nicer, but it's just because they're having to come up and then be twisted round. I always use PCI Express cables that have got the one and then you're kind of like piggybacked onto the next one, because you can get more than enough power through. So this would probably be one of the few times when I would say, if you were going to build this for yourself at home, maybe run one of the PCI Express cables which has just got one 8-pin on the end, and run this second one to go to this. So it's just, you know, run one for each. It's going to mean that you're going to have more cables in the power supply, but it could end up looking tidier. So rest of the rig, obviously Rampage 4 Extreme. The radiator in the roof is an XSPC RX360. I can say, if you have a look about now, there are rumours, well it's not rumours, they are going out for pre-order. There is going to be an RX360 V3, and they've got fittings on this side of the radiator, they've got fittings on that side of the radiator, they've got fittings on the end of the radiator to make them much, much easier for you to be able to get them in your rig and set up and made look tidy. It's brilliant. We've needed it for such a long time. They finally answered our prayers. And then we've also got the XSPC Raystorm CPU block hidden away down in there as well. Really does look the part. In fact, if I try and move the camera, there we go. We've got the Raystorm block. You can also see that I've got Corsair Vengeance Pro memory. The red one there has got the top on it, but you can take them off. So all I've done is taken the red one off of the other two, so it was red, black, red, black. But that's that there done. And then just for the sake of argument, we've got the GTX780 Neutron and a 240GB LS. This is the operating system drive where all the benchmarks and stuff are, and this is where Steam and all the kind of games and stuff are on. AX1200i powering it. It is massive overkill for this, but this is just my bench power supply. So that's your rig and your look at the card. Obviously you can see the fans here. I do like the fact this isn't black, it is actually grey. It's not the camera bleaching out the colour or the fact that the studio lights are so bright. You can see it's a really nice grey, and then we've got this anodised aluminium sections on this bit and down here, and it does all match really, really well. So I do really like the look of it. So that's our look at it in the rig and the test rig that we're going to be running today. Don't forget I said the pump was only on 2, but it doesn't impact temperatures at all. We've got the Quiet Editions here, they're on 12 volts, but the rear and the front were on fan speed reducers. Obviously Quiet Editions, these are just 140s. We run, yeah, so you know all the stuff now, don't you? I need to be quiet. We need to move on. Okay then peeps, so moving on to some light benchmarks and overclocking and things like that. We'll also cover the temperatures in this section as well. Now with the I have done some Titan testing before with an XSPC water block, so I have got some temperatures that I can directly link to, which is quite handy really. 780 in the Titan. I know there were you know, not exactly the same sort of cards, but it gives us a good idea. The Titan was not really much hotter than the 780, but like I said, it gives us just an idea of something that we can compare to, really. And obviously the Titan was with the standard NVIDIA heatsink. Oh, I can't get my words out today. But then if you can hear anything in the background, it's just some washing up being done and stuff in the background, because obviously I am in the front room and life can't stop. So with the Titan, 81 degrees was the stock, but then again 81 was the GPU boost temperature threshold. So it would just go up to that kind of temperature and, you know, go as quick as it could at that temperature. So that, you know, is just kind of how we would expect it. But the Poseidon at stock was 75 degrees. So the air cooler is actually pretty good on it. Brought the temperatures down. It still remained really quiet. It was, you know, a very good card to have not only had good performance, but still brought those temperatures down. But obviously with the water block, or with the Poseidon, how much difference did the water block make? The Titan went from 81 down to 40 degrees. Now that's on load. Graphics cards do really they respond so well to water cooling. People find it kind of confusing because your CPU, you obviously need, you know, a lot of cooling power there, because obviously you think about like your H100 and stuff, and with a big overclock you're still going to be getting, you know, 80 degree temperatures on there. That just seems to be the way that it is. But graphics cards, you see a drastic drop in temperatures. So we got 40 degrees with the Titan. Obviously that's with the XSPC full cover block, but it was with all of the same kit that you've seen me show you previously. The Poseidon, as you know, here today with that kit as well, on full load, and we tried to abuse the death out of it, was 46 degrees. But one thing I will say is there's no way with the card to completely disable the fans on it. It always runs. But it kind of has to, because you've still got those power regulators, so your MOSFETs and your chokes and stuff, they're obviously still air cooled. Now one thing that you do need to consider is, okay, we're going to be pumping water around and keeping the graphics, you know, like the main core cooler, but there's still the same amount of load on those chips, so they still are going to need some, you know, cooling to pass through them to help keep those cool. Kind of, you know, a little bit of a trade-off really. The Poseidon is more like a GPU only type of block rather than a full cover. Overclocking wise, on air and overclocked, it's kind of on air and on water. The overclock was the same, which is something was the same with the Titan, but it's something a lot of people seem to just assume, you know, will make a huge difference. But it's 954 out of the box, which then give us a boost of 1148. But then the 954, sorry, 1148 on GPU says the boost will be 1200, but it actually pushed up to 1248. So we were running, you know, 1.25 gigahertz really, and a 1250 megahertz 780 isn't, you know, it's not anything to be kind of shunned at. But you're now probably saying to me, well, Tom, why didn't the overclock go up with the water? The thing is I never play around with the volts. Sometimes I play around with the performance percentage, so you can, it's not volts as such, but you've got a percentage tool that you can kind of go in there and add the power slider up a little bit. I do play around with that, but sometimes adding too much of that can make an overclock unstable anyway. So it's not just something that you just go and slide right the way up to the maximum. But I'd never really play around with the volts, and you know, I've had cards that I've not played with the volts, and I've had 1300 megahertz out of them, 1350 megahertz 7970s. So I don't really feel the need to, especially with the newer NVIDIA cards, and definitely not the AMDs, I don't feel the need to play around with the volts anymore. I just use that performance, you know, percentage slider, and I don't do any of the, you know, overclocking where you have to click and, you know, select and say that I want to. But why didn't it make any difference with the water? The thing is the air cooler is enough to get the most out of the the graphics card as it is. The only real difference that it does make is obviously if you add the water in, the temperatures drop significantly. So longevity, do you know what I mean? You know, long-term stability, maybe component life may be impacted, but it's obviously not something that we can test in the short amount of time that we get to play with these cards. But the most important thing really is, or the most important thing to try and stress is the graphics, the actual chip itself. Dropping the temperatures isn't going to make any difference, basically. So if the air cooler is able to get the most that graphics chip has to offer, adding water to it, like I've just kind of said, you've already got the most that it's got to offer out of it before it's going to become, you know, becoming unstable. Bringing the temperatures down, like I said, may make, you know, little hiccups during the summer and stuff less likely to happen. Your parts might last longer because obviously they're not going to be running on their thermal limit all the time. But the actual getting any extra performance out of it, the air cooler is generally enough with the NVIDIA stuff. And that was exactly the same with my Titan. When we tested the Titan, we could get the same overclock, or we achieved the same overclock on water than we did on air. The only difference really was temps. But obviously when you consider temperatures, that also does mean kind of you can run have your rig running quieter. So that's really the main benefit for me that I can see. I can still run a completely on the limit overclock, but my graphics card's going to be running cooler. But obviously because of the addition of water cooling, obviously big radiators, we can choose really good static pressure fans and, you know, running with fan speed reducers. We can actually have a silent rig that's running, you know, completely balls to the wall. So that's really the way to think about it. But with water cooling, my personal thoughts are, as long as you choose the right components and keep the basics correct, then I always build them so that they look pretty and the rest just kind of, you know, falls into place. I'm not going to worry about 3 or 5 degrees over the entire, you know, build of my rig and build it so it looks like spaghetti junction. I'd rather build something where you can hardly see any hose, everything looks really neat and tidy, and I'd rather sacrifice a few degrees of temps than have that kind of monster, kind of looks like Luigi from the Mario and Luigi have just sicked up their spaghetti tea inside the case. Like, because there is a popular misconception that, oh, I must have CPU, then pump it off to a radiator, and then my graphics card, and then off to another radiator before it goes into my second graphics card. Where, to be fair, if you just went CPU, graphics, and then to your RADs, it may run a degree or so warmer, but that's it. It's a sealed loop. The temperatures just average out across it. Putting radiators between stuff it just makes everything look untidy, which is why in Orca it's rad, all the blocks, and then into the pump, and then rad. That's, you just make it look quiet. Anyway, so what we're going to do is I'm magically going to bring some graphs up onto the screen now, and we will talk through them. Ta-da! So there it is. Okay, so you can see the big red squares in our graph. And as you can see now, they're in order. We've done it by the 1080p test. But top of our graph is the 780 Ti overclock. We've not put the 780 SLI stuff that we've done in there. We've just kept this with the single cards, other than the 760 Mars. So you've got something that you can kind of go by. Now, one thing I will say is that the fact that the Poseidon has, you know, ever so slightly squeezed in front of the MSI 780 Gaming. You can see the overclock, so it's the top red square. That's actually a pretty good achievement, because the MSI 780 Gaming was that was my 780 of choice. Now, something else that I do kind of need to stress, obviously this is Catzilla and it's 1080 and all that kind of stuff, but you can follow the list up. You can see 290X DirectCU2 was a test that we did quite recently, and then you go into the Poseidon 780. Now that's at stock, so you can see that the 780 Poseidon is faster than the 290X DirectCU2 overclock in Catzilla. So, you know, straight away there, you're like, oh, hang on a minute. So my 780 is quicker than a 290X, and yes, it is. But if we move on, well, next we'll have a look at 3D Mark. And these are sorted by Firestrike. So I've done Firestrike rather than Firestrike Extreme, just because it's easier for you to kind of, you know, go by. But anyway, so that's that. And if we have a look down the list again, we can see that the stock 780 is down around below it. You've got the R9 290, and below it again, you can actually see that it's actually quicker than a stock 780 Lightning. You've got the Mars 760 above. But if you move further up to the top square where the Asus 780 overclock is, you see it's still ahead of the Lightning. It's ahead of the Mars. But you can actually see that the 290X is now a lot higher up this graph, which is quite good. But the 780 overclock, you can see, comes in just below the first of our 780 Ti's, which was the palette. We'll move across the graphs again a little bit quickly. Don't forget, you can pause if you want to pause and, you know, study the graphs a bit better. But you can see that this is Metro Last Light. Metro Last Light run absolutely balls to the wall, and you can see that we've got the two red boxes again. Now, one thing that we can see is by going from stock to overclock, we actually only really get 1 frames per second difference. So you've gone from 17.5 to 18.5 on the minimum, and then 31.9 sorry to 32.2 on the average. So not a huge difference, but obviously Metro Last Night absolutely maxed out like this excuse me, it is quite a stressful game. Even if you go right to the very top of the graph, there's only 4 frames per second difference between 5 frames per second difference, sorry, between the 780 stock and then, you know, the very top of the graph, which is the Gamewood GTX780 Ti overclock. So you know, that's a really, really good stressful game, which is why I've chosen it. But don't forget, if you want to see all of the other results, take a hit in the bottom left hand corner of the screen, or wherever the flipping review link is, and you can go there and you can see all of our games, all of our benchmarks compared with all of the other cards as well. And I think if, you know, you're really into wanting to read the review or listen to the review on this, please do go and have a look at those other benchmarks, because you'll be surprised with some of the results that are there. But anyway, that's enough of that. I think it's now time for us to move on to a conclusion. Right then, peeps, you've made it to the conclusion, and what we're going to do is we're going to, as always, tell you the award and then explain all of our thoughts as we move through. And we're going to give it the OC3D Innovation Award, because, to be fair, this is quite a brave move for Asus, because it is uncharted territory. It's trying to play to 2 completely different camps. Now, the trouble with trying to play to two completely different camps is the air cooling people are going to be, you know, turning the nose up at it, and then the hardcore water cooling people are also going to turn their nose up at it as well. So you're trying to find people that are, you know, willing to give it a bit of a chance, aren't necessarily, you know, spectacularly worried about the fact that it's not got a full water cooling block on it, and that type of thing. There's also a lot of people going on about, oh, aluminium this and all, and it's just so many. But it's like with the Maximus formula, people were saying, oh, you're going to get galvanic corrosion because the water block's aluminium. If it was bare Ali, then you could end up with some kind of galvanic corrosion ending up in your loop. But the problem is Asus are fully aware of this. You people, you know, that sat behind your computers at home and stuff, and you're just kind of spouting out stuff that you've read online. We're talking about some proper engineers here that, you know, they understand this stuff. And if it was bare, you could have a problem, but it's completely anodized. So you generally, well, you don't get an issue with it. Back in the days, there was an XSPC, it was like a passive radiator type thing. It actually had all fins and stuff up it. That was Ali, but where it's hard anodized, it stops the problems. And generally, the only times when you would get any massive galvanic corrosion would be if you had bare Ali and bare copper touching each other, and then that can be when you have problems. But you have corrosion inhibitors and stuff in modern coolants now anyway, so you know, all of those problems from years and years and years back, which are just the same things that people are starting to regurgitate nowadays, technology has moved on. The problems are still there, but they're much greatly reduced, and because of the anodizing and stuff anyway, you're just not going to get those type of issues. But anyway, so move on to kind of talking about my thoughts of this. I was a bit disappointed that the fans couldn't be completely turned off, but to be fair, I couldn't hear them anyway. And another thing is, obviously you're still going to want some air going over those, the power regulators and stuff like that. So there are going to be a lot of people that are going to kind of turn their nose up that it's not, you know, completely water cooled. But again, it's not, you know, a huge issue. There's a massive drop in temps, as we showed you. You're looking at 30 degrees drop nigh on there, and that's a humongous difference. Think about those type of levels when you're running your rig in the summer. I mean, you know, there is a possibility you'd never leave it looking out the window at the moment, but we could have a 10 degrees difference in the summer, and you're still going to be running an incredibly low graphics card temperature. And obviously, I mean, I've got these fans on 12 volts at the moment, so they're actually lit up nicer. That's why I've done it. But you can have a really low noise system as well. Anyway, so I have actually wrote some notes because I wanted to write pros and cons about this. So pros, if you think about it, you've got an air and water system. You can fit it and run it on air. You haven't got to worry. You can upgrade later on and just, you know, bang your water in, and it's just a couple of hoses. One thing I will say about while I've just pointed those hoses out is one thing I would say is where the hoses come out literally out of the side of the card, you need to make sure you have a bit of width there on your case. If you've got a really skinny case, you're going to run into problems, because you're going to need to instantly get yourself a 90 degree fitting, which is what I've done, and then into 45 to make, you know, things look tidier. So you need to think about those. It's also much easier if something goes wrong. Anyone that's worked with water cooling in the past, if you get something goes wrong, it's an absolute ball ache. Say for argument's sake your motherboard or something like that dies, and it's in case you have to strip it all down. You might have a spare board or something, but you can't use your graphics card because it's got, you know, you're trying to get it onto air quick for testing, but you can't do it because of you know, you've got the water block on it. With this, you can quite literally just unhook it all, make sure you drain the water out of it. Obviously you need to try and dry it as much as possible. If you ever did run it on air afterwards as well, I'd probably make sure I left it on some kitchen towel so the coolant could eventually come out, because otherwise you might end up with steam coming out of the side. But anyway, you can then run it on air to test your rig, so that's quite good. Also, and it's something that, I mean, we don't think about it like car sales, but a lot of us do buy components and then upgrade later on, and we end up changing. With this, when it comes to selling it on, you've not got to try and sell it with the water block on it, or you've not got to try and sell your water block separately and sell it as air. You're going to be selling to two markets. You can sell it to, you know, someone that might, you know, want either. If they want to run it on air, they can do. It's exactly the same as when you bought it in the first place. So it opens up quite a few options there. Major thing, warranty. It's a water cooled card. It's designed for water cooling out the block, but it does do both. So by fitting a water block to it, you're not going to be voiding the warranty. Now, I know it's a bit of a grey area, and a lot of us do it. If our graphics card dies, we just kind of try and put it on, but graphics card manufacturers are getting very clever with the stickers and stuff they're putting on screws and stuff nowadays, and you do have to kind of be careful reading into their RMA, you know, the fine print about whether you're allowed to do it. Most of them don't want you doing it. So with this, you've not got to worry, because you've not had to dismantle it. It's just there. You can just get on with it. Also, and it still comes up a lot on the forums, are people, if they invest in an expensive card like this, they are worried about taking it apart to fit the water blocks to it. And that's all. Do you know what I mean? Not everyone's is calm with a screwdriver about ripping a £500 card apart to start fitting a water block to it. So obviously this, it comes with it ready. You can take it out of the box, and then again you can just choose which avenue you want to go down. If you want to put water in it straight away, you can put water in it straight away, and it doesn't matter. You've just not got that you know, you've not got that to worry about. So reading when I'm trying to make a video doesn't work. I just need to brain fart it all out. So my negative points or cons: fans can't be completely disabled, but that also links into the heat, the power regulators. Obviously, you may have dropped the core temperature down by 30 degrees, but the power regulators are still being put on under the same amount of load. Now, whereas before they would have been getting a lot more fan, a lot more airflow over them because the fan speeds would have kicked up further because of the temperatures. Now the fan speeds are getting, quite restricted. So that end of the card does still get warm. There isn't a temperature probe at that end of the card. So when you look through your, hardware monitor or GPU tweak or whatever, you can't actually see what the end of the card was. But the back plate, I will say, was warm, and you could tell that the regs end of the card was warm as well. That was even with the water cooling going through. Now this bit of you could tell that the core was much cooler, but that end of the card, you only had to touch that end of the card and you could still see it was quite warm. So I would probably advise, even though I set the fans to minimum, they still went up to about 33%. I would probably set a fan profile up anyway, just so that, the fans maybe run a little bit quicker than it would want to with the water cooling on there, which is what it's going to be basing the fan profile on. So maybe just speed them up a little bit just to help keep those MOSFETs there. And that would be especially if you're going to be running a ginormous overclock. So if you're running your card on the absolute ragged edge like I was, then I would say just get those fans. You won't be able to hear it. Honestly, something else in your rig will probably be a lot louder. But if you run that, it's just for a little bit of peace of mind. I very much doubt that you would run into problems, but it's just something you can just cover your bum with. So the other thing really is the barb position, but they can't really do too much about that. The way other water block manufacturers do it is they generally have them vertically, so you can choose which side you want to connect. But like I said, all I would do is get the barbs, the 90-degree fittings, and then you can do what you want with them because they swivel anyway. This also does allow really easy options to add in a second one if you wanted to go down that route as well, because obviously you can still plumb them in. I would not have a barb going straight into this and then this massive loop. I know I'm being very picky about it, but so often I see people that they don't think about fittings and stuff, and we've had stuff on the forums in the past. So please do give your loop a little bit of thought. I've done the best I could with this rig. I don't think it looks too bad either. I really like it. The only real thing that I don't like about the card is the fact that the clips for the power connectors around the other way, and you can see the difference it made with the cable tied in on this. So all in all, it is I don't want to say it's a confused product because it's been engineered that way, and it is trying to cater to two very different ends of the market. And the air cooling side of it and the performance side of it, it does do very well. The water cooling side of it, I was surprised that the temperatures did come down that much. So they've done pretty well there. I just wish that, maybe that they found a way to send that water block a little bit further up and maybe round the like the MOSFET area to at least try and incorporate that end of the card so that you could, bring the temperatures down up there. But most MOSFETs and stuff and all that kind of shit nowadays are, they're rated for 90 or over 100 degrees. So it's not something I want to worry about. It's just because I'm used to that kind of full cooled card kind of block temperatures where it's practically bloody sat there and it's like it's just on idle. So it's, yes, I do like it. I do like the fact that they're trying to do things differently. I like the fact that they're trying to push the market forward. I also like the fact that they're trying to advance things a little bit more. But one thing I do want to cover is a lot of people have gone, why isn't it the tie? And as I've mentioned before, the reason why it wasn't the tie is because they've been doing research and development for such a long time making sure this one was right. Nvidia actually surprised everyone by going, oh look, a tie. So maybe if this one does well, they may instigate it on other cards. I actually personally think that this would be brilliant on a 290. Because obviously a bit of water on a 290 will bring those temps, you know, much lower down. I think that would be brilliant. But yeah, the reason why it's a 780 and not a tie is just because they weren't aware right until the last minute that Nvidia were even going to release that. So that's why it's come through, and they've released it anyway to kind of gauge things. Now, one thing I will say is price. It's £499, so it's not a cheap card, but again, you've got to think about all of the little things put together. You don't have to fit the card. You get your warranty, even though it's got a water block on it. You can still run it on air. A full cover block normally costs you in the realms of kind of, you know, £70 to £90 anyway. The fact that it all comes all in the box, ready to rock and rumble, and you've just got no worries. I mean, you pay a premium for stuff being ready to do stuff most of the time anyway, so I don't think it's too bad. Also, when you consider that the price of the DirectCU2 780 is still over that £400 mark, it's actually not too bad anyway. If you go looking for the cheapest 780 you can find on the planet at the moment, there is quite a big price difference, but you know, it's not going to perform as well as this. It's probably not going to be as cool as this, and it's also probably not going to be as quiet as this, even in air-cooled mode, let alone without the water. So when you do add all the little things up, and you kind of step back from your kind of fanboy just wanting to have an argument because Asus is trying to do something differently kind of attitude, you can actually see that it's not a great value, but it's not, you know, a stupidly expensive price either. We've already seen that a lot of people are actually really excited about this as well. So it just goes to show that the kind of the background marketing and stuff is there. People do want interesting and unique things like this. And let's face it, if people like Asus don't try stuff like this to see whether it's going to sell and do this, we're just going to end up with the same boring as shit fucking reference cards all the time. So thumbs up to them for doing something different. I like it, and it kind of, when Asus do stuff like this, it does make the other manufacturers start going to themselves, well, what can we do to be different now? So it's brilliant. I like it. So that's why we gave it the Innovation Award, because we like the fact that they tried to do something different. We didn't quite think it was like fully fledged gold worthy, which was why we went with innovation, but our thoughts on that was mainly based around the kind of where we knew you lot would be thinking, and that was you can get a basic 780 for this, but you know, this one costs 499 quid. But it's not to say that it's not a great card. It's not to say that it doesn't deserve a bloody good award as well, because they do deserve a massive thumbs up for it. So just trying to balance out the end there so you know where my head's been at. But for now at least, this is Tiny Tom Logan with the OC3D Innovation Award winning Asus Poseidon out.